So what we want to do is we want to find the dimensions of a cylinder so that it has a maximum volume that we can inscribe inside of a sphere that has a radius of 10. So first off, here is our sphere with a radius of, that's terrible, the radius of 10. Everybody good with that? Hopefully. We want to put inside of that a cylinder. And we want to figure out what's the maximum volume of that cylinder. So first off, what's the volume of the cylinder? It should be what? Pi r squared times h. Right? Pi r squared, the area of the base, times the height. So the problem that we have with that is that there are two different variables, and we like to convert it into terms of one variable. And so how will we do that? We need to use the idea of similar triangles. Not necessarily similar triangles. We need to use triangles. Doesn't have to be similar triangles. How are we going to do that? Here's a right triangle. Tell me about that right triangle. What is this length right here? It's the radius of that cylinder, right? We'll call that r. That's our little r there. What is this value right here? 10. That is a radius of the sphere. What is this value over here? It should be half of the height of that cylinder, right? So h over 2, or 1/2 h. And so we should be able to use the Pythagorean theorem to relate r and h together. We should get r squared plus h squared over 4 equals 100. And do we want to turn that all in terms of h, or turn everything in terms of r? What do you guys think? So you want to turn our volume equation into all r values? Nah, I like Adrian's idea better there. He says, nah, I think h is better. Why is h better? Well, we've already got r squared here, so if I just solve for r squared, then I can just straight up plug that in, right? The other way around, if I need to solve for h is going to be r squared minus 100 times 4 inside of a square root. And so then I'm going to have an r squared times the square root of something, and then like it's going to be a pain. Oh, I see, Nick. You meant r equals. So you wanted to solve for r squared is what you're saying. I don't know if we believe you, but we'll pretend like we believe you. So we're going to replace that r squared. So we got volume equals pi h times 100 minus h squared over 4. Or volume equals 100 pi h minus pi h cubed over 4. Good or no? And what does v prime equal? 100 pi minus 3/4 pi h squared. Everybody good there? And what do we want to know? We want to know when does this equal 0 and when does this undefined? It's never undefined, but it should equal 0. Let's see. When, what is that? H squared equals 400 over 3. Does that seem right? Or H is 20 over root 3. Also negative 20 over root 3, but that doesn't make a lot of sense. Good or no? All right, and we'll make our sign chart to prove that this is a maximum volume. So something less than 20 over root 3 would be like 100 pi minus 3/4 pi is definitely positive, so we're going up. And then plug in something more than 20 over root 3. That is still a possible value for H. So maybe something like 9 would work. Plug in 9 here, that's 81 times 3 is 243/4 pi. Is that right? Did I do that math right? Actually, never mind that. Sorry, H should be, yeah, 9 is small. I realized that as I went through there. Yeah, 20 over root 3. For some reason, I was thinking root 3 was more than 2. I don't know why I thought that. So how about something like, I don't know, 18. 18 squared times 3/4 times pi is more than 100 pi. So if we subtract, we end up with a negative, and it's a max. We could have also found v double prime, right? V double prime would have been negative, and then that would have been 3/2 pi h. And since no matter what h value we plug in, especially 20 root 3, that's negative, that tells us that it's a max. Everybody good with that? So a height of 20 over root 3 gives us a max volume, and we want to know the dimensions, and we want to know the max volume. So if we take 20 over root 3 and plug it into this equation, r squared plus h squared over 4 equals 100, or right here, r squared equals 100 minus h squared over 4, we should get that r is equal to, what do we end up with? This is 100 minus 400 over 12. So 100 minus 100 thirds, which would be 200 thirds. So r squared equals 200 thirds, or r is equal to radical 200 over 3, or 10 root 2 over root 3. So those are your dimensions. Plug them in if you want to find the volume. Good or no? Okay, I've solved this one like the sine curve one using a plane. Meaning what, Adrian? Oh, okay, I see what you're saying. So inscribing inscribing a rectangle into a circle. I don't offhand know if that would come out to be the same. Logically, it seems like it would, but I have a feeling that it might not. I'd have to play around with that and see. So if you want to know the answer for sure, send me a remind message and I can play around with it and figure it out. We're not gonna go through it right now, but it seems logical that it might, but I have a feeling that it doesn't work out. Just because the curvature of the cylinder is different than the curvature of the sphere. in terms of size, I mean, so hey, I don't know, I'd have to play around with it. All right, let's do one more optimization, then we'll be done with optimization. So we've got a circular cylindrical metal container that's open at the top, and it's going to have a 24 pi cubic inch capacity. And now we're looking at the cost of the materials, and we want to figure out the dimensions that will minimize the cost of the material. So first off, this is all about cost, right? We want to minimize cost, so we need to figure out an equation for cost. So cost should be equal to 15 cents per square inch for the material for the bottom. So that'd be 15 times what? How much material do we use for the bottom of this cylinder? Whatever its area is, right? Pi r squared. And then it costs 5 cents for the curved part. So our lateral surface area. And what's the lateral surface area? It should be 2 pi r times h. Everybody good with that? And just like all the other ones, the issue is that we have an R and an H. But luckily we know that the volume, which should be 24 pi, is equal to pi r squared h. So we should be able to solve that for h and replace the h. And that's it, open at the top, Delphine. No top. And so we'll divide by the pi, we'll divide by the r squared, we get h equals 24 over r squared. So our cost equation now becomes 15 pi r squared plus 10 pi r times 24 over r squared, where cost is 15 pi r squared plus 240 pi r to the negative 1. Good or no? It's all about being able to write the equation that you want to maximize or minimize all in terms of one variable. Everyone good there? Hopefully, we'll take our derivative. C prime equals 30 pi r minus 240 pi r to the negative 2 or over r squared. We'll get a common denominator, so that'll be 30 pi r cubed minus 240 pi all over r squared. We know that this would equal 0 when the numerator is 0 and undefined when the denominator is 0. R equals 0 makes it undefined, but that doesn't make any sense because we're not going to have a radius of 0. So we'll just set 30 pi r cubed minus 240 pi equal to 0 to get r cubed equals, bring the 240 pi over and divide by 30 pi, r cubed equals 8, or r equals 2 inches. Everybody good with that? All right, cool. So now we need to determine if that's a min or a max. So we'll plug in something less than 2, like 1 into your derivative. Bottom is going to be positive. 30 pi minus 240 pi is a negative, so that's going down. And something greater than 2, like 3. Denominator is still positive. The numerator now, though, is 27 times 30, which is more than 240. So positive and going up. So we've got a minimum cost when the radius is 2 inches. If we wanted to find the height, we'd plug it in over there. Height equals 24 over 2 squared, or 6 inches. 6 inch height, 2 inch radius. Everybody good or no?